Good morning friends. Today I am going to explain about semiconductors. In this topic, first of all, we are going to talk about energy bands in solids and the difference between conductors, semiconductors and insulators. So come to the first point, that is energy bands in solids. In any solids there are three types of bands will be there. What are those? That is valence band, conduction band and forbidden band. Okay, so I will give the one by one definitions for this. What is valence band, what is conduction band and what is forbidden band. So valence band means a band which is occupied by the valence electron, and a band is having a highest occupied band energy, whereas conduction band means a band that is a lowest unfilled energy band is known as the conduction band, and forbidden band means it's a energy gap between the valence band and conduction band. So to understand this one, I will give a one example. For example, if you consider aluminum atomic number is 13. If you write the electronic configuration for the aluminum, then I can write 1s2, 2s2, 2p6, 3s2 and 3p1. So this is 2 electron first orbit, okay, and second orbit is KL. L is having 8 electrons, and in the third orbit, that is KLM. So in the third orbit, how many electrons are there? That is only 3 electrons are there. So these 3 electrons are known as the valence electrons, and the particular band in the atom which is occupied by the valence electrons is called a valence band. Okay, so to understand this one, just imagine this is positively charged nucleus and this is the outermost orbit of an aluminum atom. How many electrons are there? These are 3 electrons are there. So this particular band is known as the valence band. Okay, the electrons in the outermost orbit of an atom is called the valence electrons, and the particular level or particular place which is occupied by these valence electrons is called the valence band. Okay, and next higher, and this next band which is the lowest unfilled band is called the conduction band. Okay, this one is called, what is the definition for the conduction band means the lowest unfilled energy band is known as the conduction band. So in the next band will be the conduction band, and the gap between the valence band and conduction band is called the forbidden band. Okay, so to understand this one, you can consider this one. Forbidden band means the energy region between the valence band and conduction band is called the forbidden band. So I hope you understand this one. What is valence band, what is conduction band and what is forbidden band. Okay, so now come to the point, that is difference between the conductors, insulators and semiconductors. Based upon this band theory, or based upon these three bands, that is valence band, conduction band and forbidden band, these solids are classified into three categories, that is conductors, insulators and semiconductors. Conductor means which are easy, conductors are those substances which easily allow the passage of electricity, means all metals, for example. So why, what's the reason? Because in case of conductors, these bands, valence band and conduction, the representation of these bands in the solids are like this. Okay, so just now I told you how many bands are there, that is conduction band, valence band and forbidden band. So in case of conductors, this valence band and conduction bands are overlap to each other. So like this. Due to this overlapping, the electrons from the valence band are easily enter into the conduction band, so which are responsible for the electric current. So this is known as the conductors. Okay, so this is the band energy in electron volts. Okay, so this is the representation of bands in conductors. In case of conductors, valence band and conduction bands are overlap to each other. Due to this overlapping, the electrons in the valence band easily enter into the conduction band, which are responsible for the electric current. Okay, so I wrote this one. Conductors consists of a large number of electrons. In case of conductors, valence band and conduction bands are overlap to each other. So I shown in this figure. So due to this, or due to which electrons from valence band freely enter into the conduction band, hence a slight potential difference will be established across the conductor. So due to this overlapping, electrons are moving, so and potential difference will be established across the conductor, which causes the free electrons to move through the conductor and constitute the electric current. So what about insulator? Insulators means that is which are insulators are those substances which do not allow the passage of electric current. Why? What's the reason? Because in case of insulators, the valence band and conduction band is having a very large gap. Forbidden gap is very large, that is approximately 15 electron volts. Okay, so I will draw this diagram for the insulators. In case of insulators, why these are behaves like insulators? Because in case of insulator, valence band and conduction band is having a means which the gap between the valence band and conduction band is very large, that is approximately 15 electron volts. So that's why a very high electric field is required to push the electron from this side to that side, conduction band. So that's why at room temperature those are behaves just like a insulator. If you give a very high electric field, so that time the valence electrons will enter into the conduction band and the electrical conductivity will be increases. But that is very for that situation we should have to give a very high electric field. Okay, so anyhow, so why these are behaving insulator? Because of this gap, that is forbidden gap is very large, so due to which those are behaves like insulators. For example, that is insulators are those substances which do not allow the passage of electric current through them. Here examples are wood, mica and plastic. Now in case of insulators, the valence band is full with the conduction full, while the conduction band is empty. So in this valence band is always full filled with electrons and this is empty. Okay, so the gap between the valence band and conduction band is very large, that is approximately or the order of 15 electron volts. So due to which a high energy is required to push the electron from the valence band to the conduction band. So for this reason the electrical conductivity of such material is extremely small and may be regarded as nil. Okay, under ordinary conditions. Semiconductor means whose electrical conductivity is lies between the conductors and insulators. It means these are the insulators. And semiconductor means whose electrical conductivity is lies between conductors and insulators. It means here the energy gap between valence band and conduction band. This is conduction band and this is valence band. So the the energy gap between the valence band and conduction band, that is forbidden gap, is very small, that is just 1 electron volts. So that's why a less electric field is required to push the electrons from this side to that side. At room temperature, these semiconductors are behaves just like a insulator. But if you give a electric field and due to which the electrons move from this side to that side, as you give the high electric field, the electrical conductivity is increases of this semiconductor. So like that, semiconductor means whose electrical conductivity lies in between conductors and insulators. Okay, so in case of semiconductors, the energy gap between valence and conduction band is very small, that is approximately 1 electron volt. That is a very smaller electric field is required to push the electrons from valence band to the conduction band. So that's why the semiconductors behave as insulator. As the temperature increases, more valence electron cross over to the conduction band and the conductivity is increases. Okay, thank you. For more videos, subscribe my channel Physics.